We have two presenters. We have Robin Lowell, who's done several Code Jumper webinars for us, Senior Manager Accessibility with I2E. And then also joining us is Shelley Mack, teacher of the Visually Impaired and certified Braille transcriber, and Braille consultant for OCALI. And let's talk about some challenges now, some things that may be things that you're dealing with. There's a lack of access to accessible STEM curriculum for educational aids. It really is something that has been a problem for a long time. General ed teachers may very well not be aware of accessible options, and that may be partially because of how few there are. The mindset of teachers and of students at times is that coding is not an option for a lot of the students, that it's not really something that they can do. So we want to address those today. And our learning objectives, we're going to describe the importance of Global Accessibility Awareness Day and how Code Jumper can expand digital accessibility to students. We're going to be able to explain at least 3 ways that Code Jumper can engage students in block coding. List at least 3 ways students can express their understanding of block coding concepts using Code Jumper. And finally, list 2 ways that Lesson 9 constants can be implemented in individual instruction. And with that, we're going to begin with Robin.
Robin,
there's an unmute button. There's
there you
a
go.
Crazy button that you push that you can magically hear. So I apologize in advance. We are getting new fire hydrants, which is always exciting. So there's a little bit of noise. So why was Code Jumper created? So thinking about those objectives, that access, that is a huge piece here. So that is why Code Jumper was created. A researcher for Microsoft who is in the UK has a child with a visual impairment, and there was nothing available for her child to learn coding. And so she took it upon herself, well, we're going to make this happen. And so she, being a researcher, was able to have the resources and the time and the backing from Microsoft to create Code Jumper. So Code Jumper was created as an accessible experience for not only students who are blind and low vision to access coding, but her thinking was that this is an opportunity for all students to engage in hands-on experience of coding. Thinking about that idea of, is coding available, or should coding be available to all students? And the answer to that is a resounding yes. Yes, it should be. And some of you have heard me say this before, but that idea of yes, I can code is critical for our younger students, because again, the idea that if you have a mindset from an early age of yes, I can, it's much easier to change in the early years than it is to change, say, in middle school when you have access to a text-based coding. So let's talk about really what are some of those differences. So we have text-based coding, which is you see in all of the movies with all the parentheses and commas and lines and lines and lines of text, that is the code. But most programs for beginning coding are actually block-based. And what this is think about a puzzle. It's putting together instructions in these blocks that you drag and drop on the screen to have to basically create directions, create code. So there's great programs, and up on the screen right now we have 2 examples. One is Microbit and the other is Scratch. And both of these programs are really great if you can see what's happening on the screen, because what's happening is you drag in the commands. So you have a character. The game on the left pretty much looks like old school Pong, one of the very first video games, which I can say I actually had as a kid. And so you have a ball pinging from one side to the other, but you have to move and put the commands in to move basically the paddles to knock the ball back and forth. So you can, or go through a pathway, which is great. You can help design it, but that's only half of the experience. You don't get to have that output. So you can help design it, but you're not seeing what actually happens. And then the other example is Scratch, where again, you're matching and you're dragging in these blocks of code and connecting them together to have this super cute kitty cat do something on the screen. But that's great. Again, if you're blind or low vision, you can help come up with the plan, but you don't get to see that outcome, which is critical, that whole entire experience. So CodeJumper really fills that gap. That's filling that gap between being able to just participate partially to being able to, from start to finish, create a program, design the code, create the code, and then run the program. Because CodeJumper being multi-sensory, where you're physically putting the pods together, you can tactily feel what's happening, and then running the program and figuring out what sounds you need. So you hear the program start to finish. So this idea that CodeJumper fills this gap to be able to have this full experience for all of our students, beginning at the much younger ages of kindergartners, because I've used it with kindergartners, I've used it with middle school kids, of creating a mindset and creating this opportunity of, yes, I can code. So if we skip ahead to the next slide, Paul, that would be great. We're going to watch a video, and this is actually Cecily Morrison, who is the researcher that I was telling you about, talking about why CodeJumper there is that need for it, and as well as our own Greg Mutter. So Paul, if you want to go ahead and start the video, and we'll talk a little bit about afterwards.
Project Torino is a physical programming language that allows children ages 7 to 11 who are blind or low vision to access the computing curriculum.
Students learn, if I take this device and plug it into this device and plug it into the hub, that creates a loop. It could be music, so they may be able to loop a couple notes together. They can create a repeat, they can add additional notes. The possibilities are endless.
The huge benefit of Torino is it's a physical environment. The students can actually touch and manipulate the different elements that make up the programming environment.
Each pod is a statement in your program. It's one line of code. You then put those pods together to create those lines of code in your program. Many of these kids come in with a whole set of skills ripe for computing.
Yeah.
And we just need to give them the tools that allow them to grow that talent.
Programming is an ideal potential job opportunity for visually impaired people. They actually make up approximately 1% of the programming community worldwide.
It's either the top one or the bottom one.
It's the bottom one you need to change.
It's an environment that will work for any student that is a tactile learner. Because it's accessible, it allows you to immediately engage with the concepts of programming. It allows you to immediately create programs that work.
If this one was on 8 and that was on 1, this one would play because the number is higher.
Particularly in this case, where there's quite a specialized market, we needed to partner with someone who really understood that market and really understood how we would get a quite advanced technology into the hands of the kids that it would be most impactful for. APH know how to do that.
Microsoft handed us this project name of Torino, and we decided on the name CodeJumper. And they said, take all this research and time and energy and money we've spent and help us get this into the hands of students and be a partner with us.
Our hope is that we inspire all blind and low vision children to code regardless of where they are.
I think we only need 2 because then the next one there's more than 1 note.
Yes.
Then we put a pause in between.
Yes, that's fine.
There's been lots of light bulb moments where they've suddenly understood a concept, where they've been able to track through the program physically as it's running. So they've been really enthused about Project Torino. And as a teacher, that's what you want to see in your students. You want to see that level of enthusiasm to learn more.
It is an active, hands-on learning, hitting at those most concrete and operational levels for a student. And I think it's just the beginning of what's to come for this field.
Great. So thinking about this, that idea, there's a need that needed to be filled. So they created this. Last night, I actually had the opportunity to be part of a panel where we're talking about equity in special education as part of a broader conference. And it was really interesting to hear the panelists talk about what equity is. And what we kept getting to was this equity and thinking about ensuring all of our students have what they need with the goal of that post high school, college, or job world, ensuring that those students have the skills ready to be out in the workforce, higher education, wherever it takes them. And this is that beginning spot. So there are so few, I think the statistics are, there's like 1.4 million open computer science jobs in the US. There's only 400,000 students in computer sciences that are majoring in computer science. There's a huge gap. And our students who are blind and low vision, there's so much opportunity there to tap into this. It's an untapped market. And again, it goes back to, starting that computer science, those skills at an early age. So that way, when they're ready to go into those fields, they have that background knowledge, but they also have that idea of, yes, I can. So with that, I would love to turn it over to, actually, Paul, can you go one slide forward to make sure I didn't have one more slide. I think that was the last of my, oh wait, sorry. I did have another slide. I was getting on my soapbox about careers. So thinking about what computer science really does. So there's the core practices of computer science. So there's an organization called K12CS, and there's this wheel on the screen, and there's really 7 areas that we're looking at around what computer science is teaching our students. So you can take all these skills that you're learning through computer science and take them out of computer science and apply them to so many different areas. I've had opportunities to brainstorm of what other areas does CodeJumper kind of apply to, and it's huge. So the core practices of computer science are fostering an inclusive computing culture. Again, that's what we were just saying, like this webinar that I was on last night, an inclusive computing culture, creating an environment and a mindset, welcoming all different people into the field of computer science, collaborating around computing. Yes, that's that social piece. It's that being able to collaborate and communicate effectively, written, orally, all those different ways. Recognizing and defining computational problems. That problem-solving skills are great because in computer science, failure is part of the process, and it's something that is encouraged to fail and then to get back up and then be like, where's our problem? And they even have a special word for it called debugging. It's like, okay, let's go and debug and see where the problem is. Is that you're never going to move forward unless you figure out your problems and you make those problems. Some of the greatest ideas and creations come from failures. And then developing and using abstractions. And this is so hard for so many people, that abstract concept. And how do we take these abstract concepts, make them concrete, and then use them? So my example is a student that I had who was a middle schooler, was doing text-based coding and was just really struggling with that idea of loops because it was so abstract. We then built it in CodeJumper, and I was like, oh, okay, now I understand it. And then it could take those abstractions. Creating computational artifacts, building a program, creating these artifacts. CodeJumper does that, and so does Scratch and all these other programs, but creating these. And then you get such a feeling of satisfaction. I built that. Testing and refining computational facts. It's not one and done. Back to that, recognizing and defining computational problems. So if you look at the design thinking process, there's the all the different ideas you have to iterate, and then you have to prototype, and then you have to problem solve, and you have to test, and then go back and then ideate again. That didn't work. So it's these ideas of that testing and refining, which is so critical for so many students to think about. And this is such a great opportunity to learn that. They're like, okay, I did it, moving on. It's in the past. But helping our kids realized that pausing long enough to go back and think about where is my mistake, or how can I improve this, and be willing to go back and test and try and refine before moving on. And then communicating about computing, being able to talk about it. And if you have any gamers in your life, which I know I do, the things I'm hearing from my 9-year-old, I didn't even learn until college. And it was phenomenal to hear this language that comes from like the kindergartners talking about algorithms, and middle schoolers talking about if-else statements in a way outside of a two-dimensional math problem in their textbook, and applying these and talking to each other in this high-level language that they learned along the way, that's become the norm. So all of these practices of computer science, we use them in computer science, but then we can take it out and apply it. And the expanded core curriculum is a great area to think about, where we can use all these core practices of computer science and writing and math, and all these areas are all tied together, but it's creating this framework of understanding and a lot of skills that could be even tied to the social emotional learning of finding problems and having the skills to go back and fix them. So this is something to really think about as far as those ideas of why we need to be teaching our students computer science. With that, I think, Paul, can you go forward one slide, please? Okay, so that is the end of my section, and I'll turn over to you, Paul, so you can talk about our poll question.
All right, thank you, Robin. We have a question for you now. Betsy Ann, if you can throw that up there for everybody. Thank you.
Got it up.
So, do you believe that coding is an important part of your students' educational experience? Do you believe that coding is an important part of your students' educational experience? Your choices are: no, coding is not important to my students. It's good to know, but not necessary. Or yes, coding is an important part of my students' education. So where do you believe it fits in? No, it's not an important part. Good to know, but not necessary. Or yes, it's an important part of my students' education. This is also a really good time if you have questions for Robin. Throw those out in the chat as well as you're completing this poll question.
Nothing in the chat just yet, but we do have people completing the poll, so thank you. Ooh, one new thing. So one of our audience members shared the idea that this gives students an additional language is huge, an additional way for them to expand their circle of possible friends. Yeah, absolutely. So many kiddos, just like Robin was sharing, are into gaming, and computer science is so integral to gaming. I can imagine friends sitting down around a code jumper and enjoying coding together, and enjoying not only their successes of being able to make code jumper play the song that they'd like, or tell a joke, but also enjoying the burps that the code jumper creates when you have a bug in your system. So thank you for that. And feel free to put any other thoughts or questions in the chat. I'm going to leave it open since we've got a really intimate group here with us today. About 44% have voted in the chat, so please take another look at that question. Do you believe that coding is an important part of your students' educational experience? You can also give us some feedback in the chat if you have a more specific answer to that question. But so far, 83% have said, yes, coding is an important part of my students' education. And we have a few folks who say either no, coding is not important to my student, or it's good to know, but it's not necessary. So thank you everyone for completing that poll. And we are going to go back into our presentation.
So hello there, I'm Shelley Mack, and I'm going to be sharing my story with you about Code Jumper and my teaching experience. So we're going to move to the next slide. First of all, a little bit about myself and my position as an itinerant teacher of the visually impaired. I've been a teacher for about 30 years, with about 25 of those years being as a TBI, and a transcriber for about 32 years. I also work as a Braille consultant for the AT&AIM Center at OCALI in the state of Ohio. And so in that position, I conduct Braille-related workshops and summer courses. As an itinerant, I'm also a private contractor, meaning I don't work through an agency or directly on a normal teaching contract. I serve students in 7 school districts in smaller cities and rural areas just south of Cleveland, Ohio. And my typical caseload is close to 25 students, and that, goes up and down year to year. Currently, I have students from 3 years old to 12th grade. I have 2 graduating seniors this year. And so we'll move to the next slide. So I'd like to give you a little information about a particular student of mine. Who is a Braille user. He's a 7th grader in a rural district. He's congenitally blind and has no light perception. I've been with him since preschool, so we've been together a while here. Academically, he is completely at grade level in all his core courses and everything. He uses a note taker for most of his schoolwork, though he uses a Perkins Brailler for math. And then he also kind of sporadically uses his Windows laptop with NVDA. He has a great personality. He's very social, enjoys music, and he plays percussion and keyboards with the school band. In the past, if you asked him what he wanted to do, he would tell you a professional wrestler, something that his dad and his brothers really get into. So that was about the only goal he could think of. And so we'll move to the next slide. So next, I'd like to talk about the intersection of coding and a pandemic. So this diagram shows a typical day in the life of an itinerant, which many of you may be able to relate to. It's a never-ending circle of teaching, driving, transcribing, email, and paperwork. I forgot to throw in into the circle the million meetings in a typical school year. If you're looking for lunch, you pretty much eat that while you're driving. The onset of COVID-19 and remote instruction threw everyone for a loop, and that definitely included me. There were suddenly all these new ways to use technology, new websites to learn, new everything to learn, and learn it as quickly as possible. We were told on a Thursday that there would be no more in-person school by Monday. And so all of a sudden we had 2 days to put everything together. As an itinerant, I also had to keep up over time with the ever-changing schedule of my schools. So some were totally remote at times, some were in person, but only for certain students, and some were hybrid. And so all of their schedules changed pretty much from week to week, it felt like. Most of my districts went completely remote around Thanksgiving of 2020. And in all of the change, the big picture of my students' schedule, that 7th grader that I introduced you to, sort of slipped my mind. His middle school has a program of 4 quarters each year of these 30-minute daily classes. So there's a quarter of PE, technology, foreign language, and art. In 6th grade, the technology was an introduction to keyboarding and Microsoft Office products, which was absolutely perfect for my student. It was great skills that he needed to work with. I had assumed that the 7th grade technology quarter was a continuation of that, and the student was supposed to be scheduled to have it during the 4th quarter. In late January of this year, the district returned to full in-person instruction right at the end of the semester on the last Monday of the 2nd quarter. So I found out that day that the student was supposed to start technology the following Monday. So I had 1 week to prepare, and the topic was coding. So in a panic, I first checked the online program that the students were going to be using to see if it was compatible with a screen reader. And in a nutshell, it is not even close. Even if it were, all of the activities were visual in nature. So they did things like creating logos or manipulating pictures and things like that. So then I thought of Code Jumper kit I had ordered the summer previous to that on quota funds, thinking I would use it with the student as sort of an enrichment activity at some point. I had kind of watched a couple webinars on it, read a couple articles. I hadn't actually opened the box yet. So I very quickly learned about it. I got permission from the principal and the technology teacher to substitute the Code Jumper curriculum for their curriculum. I promised to write notes for the technology teacher about activities that we did so that the student could get grades for assignments. And I spent the rest of the week looking at the first few Code Jumper lessons and trying to figure out how it worked. So that was the start of our coding experience. So we'll turn it over to Paul.
Hey, Paul, I think you might be on mute. I know it's a challenge we're all having these days, when we're mute and when we're not.
Okay,
we did get.
I'm hitting the keystroke and I'm in the wrong application when I'm doing it. Okay, there we go. So we're talking about technology, and Shelley was talking about how she was relating to it. So the question is, how do you approach your relationship with technology during this past year? I was frustrated, nervous, or overwhelmed by the change. I was excited for the challenge, or I was finally in my wheelhouse. We're all a little different when it comes to technology. So how have you felt about it for the last year? I was frustrated, nervous, or overwhelmed by the change. I was excited for the challenge, or I was finally in my wheelhouse.
Thank you, Paul. And while we're answering this poll question, we had another comment come through the chat. Coding can lead to new learning and the possibility of opening up post-secondary options that we need to help expose our BVI students to it. So exciting. Absolutely. And we all at APH, anybody who's heard Shelley's story of the incredible progress her student made, it's just a really heartwarming, but also inspiring story for teachers out there, to know that it is possible in a week's time to turn around a coding curriculum using Code Jumper with a student. That's, as any traveling teacher knows, that is a feat in of itself. So congratulations, Shelley, for having the 2020 vision, in fact, to go ahead and order that Code Jumper, not knowing when and how it was going to be used, but then having the perfect place and time to use it. So a few folks have dropped some ideas in the chat. Actually, I'm both excited and overwhelmed. Absolutely. I'm sure there are a lot of folks out there who are feeling both excited and overwhelmed simultaneously. Tech moves too fast for the caseload size. No extra time to learn all the new everything. Oh my goodness. If that isn't something that Shelley and Robin are nodding their heads at, that with large caseloads, it can be hard to find that time to address every student's needs and to make sure that you're up to date on the next horizon, which is computer science and coding. Absolutely. Mostly the first one, due to my customers. I was also excited as I was able to get more training and increase my tech skills. So absolutely, the pandemic, while it has provided us so many challenges and so much terrible loss, it's also provided many of us the chance to really lean into technology and find out for ourselves how useful those basic computer skills can be. So thank you for your comments in the chat. We've had about 40% vote in our poll, so take a moment and look at that poll question. I'll read off where we are so far. How did you approach your relationship with technology during the past year? 67% said I was frustrated, nervous, or overwhelmed by the change. Super normal feeling to have. 25% were excited for the challenge. 8% said I was finally in my wheelhouse. And for some of you, you had mixed emotions about approaching a new relationship with technology during this very challenging and very unexpected year. So thanks everyone for looking at that poll question. I'm going to end polling, and Paul, I'll turn it back over to you.
I think we're giving this back to Shelley.
Back to me.
My
Okay.
apologies, Shelley. It's all you.
Yeah, that's okay. Thank you. So now about the experience itself. I went in with two main expectations. The first one was to learn coding, whatever that meant. I love math, but I knew nothing about coding. Though in hindsight, I realized that I actually used coding when I used to transcribe with the old Megadots Braille translation program. So there were coding things that I was doing, just didn't have the word for it. The second, more important expectation for me was to survive the quarter class. I just wanted to get through the 9 weeks. The class was 30 minutes a day for the 9 weeks. Subtracting travel down to the cafeteria where they had it, unpacking and packing because I had to drag the Code Jumper case with me every day. And it was closer to about 25 minutes or less a day. With only those expectations, amazingly to me, there were quite a few favorable outcomes, which easily exceeded my expectations. The first favorable outcome was that the student learned the basic skills and vocabulary covered in the regular class plus more. So whereas the regular class had, over the quarter, they covered 10 vocabulary word concepts, we covered closer to 15. In the course of the quarter, we completed 14 of the 19 Code Jumper lessons. The lesson plans were very easy to follow. And a lot of the times, my student and I were just kind of working it out together. The student was super, super proud of what he was accomplishing, and took any opportunity that he could to share what he was doing with his classmates and teacher. When his teacher walking around the room would come around to observe him working on something, I always had the student explain the coding concepts that he was working on to the teacher. So the teacher didn't just think that the student was like playing with a cool toy, that he was learning coding. We worked right in the same classroom as the coding class, so the student was still with his peers. One little sidebar about that, being with his peers, one aspect of Code Jumper that he wasn't crazy about, thinking of him as a 7th grader, was that the singing sounds, and you got a little taste of it in the video that they showed earlier, are in little kid voices. And so he tended to turn the volume down during those activities so the other students wouldn't hear it as clearly, thinking that it sounded a little bit childish for middle school. Another good outcome was a growth in fine motor skills. Code Jumper required everything an OT would be proud of, working with 2 hands together, manipulating the pods and the cords, plugging and unplugging. It was fantastic. At the beginning, it would take quite some time for the student to find the correct pods or put them away or figure out how to plug them together. But by the end, his speed and coordination were much, much improved. It was really cool to watch. The next good outcome was a growth in computer and screen reader skills. You can use an app with an iPad, the Code Jumper app on the iPad, but we used it on his Microsoft Windows computer with NVDA. And so it gave him, Code Jumper gave him very good, specific, solid tasks to accomplish using his keyboarding and command skills. And then also writing notes along, writing his vocabulary words and things on the computer. It was just a great There was a great growth in his computer skills. Probably my favorite outcome was a shift in employment goals. Even before the coding class, he started to realize that perhaps being a professional wrestler was not really a realistic goal. But now if you ask him what he wants to do as an adult, his answer is to either be a coder or work in some area related to coding and computers. Much more realistic goal for him. And then the final good outcome was a growth in problem-solving skills. CodeJumper gave the student tasks to accomplish and problems to solve while learning coding skills, but in fun ways, in very non-threatening ways, and most importantly, independent ways. I always gave the students a day at the end of a lesson, and a lesson usually took a couple of days to do. Usually 2 to 3 days, depending on how much content there was in it. And then I would give him an extra day to do whatever he wanted. And there were 2 lessons in particular that when he was doing his exploring, what he ended up doing led him to do something from either the next lesson or a couple lessons later. It was very cool to see that. In one particular lesson, the student created the song Make New Friends, which ran perfectly. And then he used his exploration day to add a second thread to the code so that the song played as a round. So this was one of 2 of his lessons that I made a video of, mostly so that he could hear it whenever he wanted, but also to show his parents what he was doing. And so on the next screen or next slide, we have the video.
Make new friends, but keep new friends, but keep the silver and the gold. A circle is round, it has no round, it has how long I want to be your friend. I want to be your friend.
And that was his pride and joy. It sounded pretty cool. And again, even though it was little kid voices, that one he actually let kids hear. And that's about it for my experience there. So I will turn this over to Robin. Oh, sorry, Paul.
Yep, it's time for our last poll question. So we would like to know, after hearing Shelley Mack's experience, has your level of excitement changed in regards to teaching coding? Yes, my level of excitement has increased. No, my level of excitement has stayed the same. Has your level of excitement changed now that you've heard Shelley's experience? Yes, it's increased. No, it has not increased. You can answer that poll question as you add any other comments you want to, or questions in the chat for Robin or for Shelley.
Yes, we know after Shelley's presentation, you were already excited and your level of excitement has stayed the same, or we know that your level of excitement has increased after hearing that story. We had a question come in about how tied to math is CodeJumper, which Robin responded to in the chat. But just to share with folks, I'm a math novice, as you might have been able to tell from my early trivia with Robin. And I really enjoyed looking at the CodeJumper and the CodeJumper lessons. I think the way it's tied to math for me is that logic and the sequential ordering of a problem. We all know for math, that's such an important part, is figuring out where to start to figure out where you're going to end up. And that's a key learning element from CodeJumper, is being able to plan your work and then work the plan. So thank you for that question. Even people who I think are not mathematicians or math teachers or really feel strong or confident in their math can definitely teach CodeJumper. It doesn't require advanced calculus, even advanced algebra. It'll take what you bring to the table. So about 62% have voted in our poll, and 100% say, yes, my level of excitement has increased. So thanks, Shelley, for sharing that story. It's a great story. I love that, you know, while I'm sad that the world has lost a potential, you know, the next Rowdy Rod Piper, I am really excited that that student is on a really keen path towards computer science. So Robin, we've got 45, we're at 45, so we've got 15 minutes left. It'll take us just about 3 minutes to wrap up. So math says 12 minutes for demonstration. So let's share our screen. Woohoo!
So I'd like to take over sharing. And let's see here. Yes. Share screen. Share screen. Okay, so we should be seeing on the screen Code Jumper. Let's see here. We should be seeing this Code Jumper curriculum, or is that what everybody's seeing? Shelley, is that what you're seeing? Okay, good.
Yeah,
I have 3 screens, so I'm never sure exactly which one it's going to actually share. So where I am right now is I am at the Code Jumper website, and I'm looking at lesson 9, which is the one with that we just heard for Make New Friends. And so what I would like to do is actually create this. So this lesson is about constants. And before we do that, I'd like to back up just a second and just talk about that, you know, coding is not something that most TVIs went to school for, nor mathematics. But the way the curriculum is written is that teachers are learning alongside their students. It's really, you know, no prerequisites are necessary. You can learn along and sit alongside your students and learn with them. And kids love it when they can teach you. And that's a great opportunity for that. So from that fear perspective, oh, I get that. But the way the curriculum is written is it's written for someone with no coding experience, so you can learn right alongside them. So I'm in the curriculum right now, and we start out with each activity has step-by-step instructions from unplugged to the guided activities, which are really those teacher-student more working together, and then the exploration where the student can go off and create a round like Shelley's student did. So there's pictures included and of what we need to be doing. So we're going to create what Make New Friends actually looks like, and we're going to be using constants. So I'm going to go ahead and change my screen. So now what we have on the screen is I'm using a dot camera, so we can see the Code Jumper pieces, which I'll talk about, and then also the Code Jumper app. And so I pre-built this just for the sake of time, but I'll explain what I have going on here. So I have the hub, which is where the Bluetooth, well, it's the biggest component of Code Jumper, and it connects to the computer via Bluetooth. There's a speaker and the stop and play button, and that is connected with a short cord to the loop pod, which has 2 cords coming out of it where we can create our loop, and then 4 play pods, and each play pod is where we create our lines of code. So in the app, we have our loop pod shows, it's yellow, it's grayed out, and you'll see why in a second, and then 4 play pods. But I'm going to actually change this from Twinkle Twinkle sound set to Make New Friends. And okay, just change it to Make New Friends. So I'm going to press play and let's see what happens. All right, a burp. You hear a burp. And that's Code Jumper's way of telling you that I have an error. Okay, so something is not right. It's not put together right. So I need to figure out where my error is. And looking at this, you get to know your pods and where things need to be plugged in. So right now, looking at our loop pod, which is white and yellow with a short, squat, yellow donut-shaped dial. And then coming out of the end, I have a cord that's plugged to the hub, and then one that's going to the rest of my loop. Well, this one's plugged in the wrong spot, so I have to unplug it and plug it into the other port that's below that. Okay, So now it's not grayed out in the app. And if I press play, we will hear the program. But right now, it's set to loop 5 times, which means a loop means how many times are we going to play this program? So I'm going to turn the dial on the top to play. I'm going to have it play once first, just so we know that our program is correct. So
6, 7, 8, 1.
Okay. So when you turn the dial, you can hear what's happening. So I want it to loop 1 time by turning that dial. Okay. So we have constants. And so for those of you who remember your algebra, and an X is a variable and a constant is basically a number. And in CodeJumper, we have 1 through 8. And because there's 8 sound slots, each sound set has 8 sound slots, and each sound is in a specific sound slot. So they're in the program in order. So we want to play Make New Friends. And I'm not going to torture you with me singing it because that would be terrible. So we know we want the song to start out with the first line. And say we don't even know this song. So I'm going to take constant, and on the top of the constants are tactile markers. And so this one has a raised dot for a 1. And they're created more like dice as opposed to Braille numbers. So you can visually look at them and know. So again, that multisensory aspect. So the constant with 2 dots on it is the 2, and also on all the way up to 8. So on top of each of these play pods, each one of them are blue and white. There's 2 dials on top. The sound dial is short, shaped like a donut, and has lines around it. So we can change our sound. So I'm going to turn that.
Make new friends. That's how long.
Okay, so that when we turn those, we can choose our sound. And the tall ridge dial.
That's how long I want.
So that right now, that changes the speed of the sound. So you can speed it up, slow it down. But we want this to go in order. So I'm going to press play really quick.
That's how long I want to be your friend. A circle is round.
Okay, we already know they're out of order, but using constants, we can put them right back in the order without having to turn each dial. So I'm going to put the first constant, number 1, into the sound dial. There's a little port on top. We heard that click. So now we have the right sound is there with the constant. So the second sound is in the second sound slot. So that's constant 2. I'm going to insert that into the second play pod, which is connected to the first. Heard the click. Third constant into our third play pod. And the fourth constant into the last one. So because we know this sound set has 4 sounds, we can have up to 8. So the nice thing is our loop is actually created in a circle, like a loop would go around. So now let's see how this is working. So I'm going to press play, and play is either on the hub with a big inscribed circle with a triangle, or you can press play in the app, either way. So I'm going to press play on the hub, but as I go, I'm going to touch each sound pod so I know where I am. And so in case there's a bug that we need to fix, let's see, here we go.
Make new friends, but keep the old. One is silver and the other's gold. A circle is round, it has no end. That's how I want to be your friend.
Well, we have the sounds all in the right order, but the end of the song got really excited there and went really fast. So that's aha. We have to debug this. So I turned my sound dial on pods 3 and 4, and I know they're 3 and 4 because I was tracing my code. Oh, that's the wrong direction. Too slow.
A circle is round.
Okay, and I'm gonna do the same on my 4th sound dial and on my 4th pod on the speed.
That's how long I want to be. That's how long I want to be.
And I'm stopping the sound by pressing the stop button on the hub, so we don't have to listen to the whole thing. So I'm going to press play one more time and see if we have debugged our program.
Make new friends, but keep the old. One is silver and the other's gold. A circle is round, it has no end. That's how long I want to be your friend.
All right, so we were able to debug and figure out our own mistakes and fix them. And we learned the concept of a loop, the concept of a constant, which is a fixed value, and debugging. So just alone in this what we took 10 minutes, we learned 3 concepts in computer science. And in the program and the curriculum, you go in more depth and learn more details about each concept, and they build one upon the other. And you start with sequence and algorithm and move all the way through networking. So it's pretty fantastic. So that's just a quick demonstration of how CodeJumper works. And this is from lesson 9. So there's a lot you learned before that. So if this was a little overwhelming, that's okay. You've already had 9 lessons to learn how to get to this point. So with that, Paul, I'd like to turn it back over to you.
All right, perfect. So let's now talk about what we have discovered today. Get that slide up there for everybody. So we've discovered several things. Coding is for everyone. So it's not for just certain people, certain ages, certain groups. It is for everyone. Over the past year, technology has definitely provided another layer of access to content for professionals, for everybody beyond K-12. So not just for kids, but for everybody. Technology has really changed the game. Valuable career opportunities for students exist in technology and coding. Maybe they're directly in coding, maybe in something related, but the coding helps out. And teaching coding can lead to unexpected outcomes, as you heard from Shelley. Her student changed his idea of what he wanted to be after he had done this. So in our final slide, let's just show you CodeJumper one last time. Remind you that you could go to codejumper.com and see the lessons. You can get all kinds of information about how it works beyond the basics that we've covered some today. It is a quota product available from APH for $795 on quota. It's also available for cash sales for $999. So feel free to go to the APH website, aph.org, and get information, or go to codejumper.com and just check out the different things that are available. Lots of resources there, and that may help you understand even better what exactly CodeJumper can do. So we appreciate you joining us today and sharing some time on Global Accessibility Awareness Day with us. So thank you very much for doing that.